Okay. Again, welcome back. So in chapter 3, we completed the chart. It was a chapter on demand and supply. So in this next chapter, which is chapter 4, we're going to talk about how do we merge demand and supply together to determine what we call market price. So we're going to be talking about the concept of equilibrium. And equilibrium, again, as I wrapped up the chapter 3, I mentioned that is when two opposing forces come into balance. So it's the idea that if producers are willing to supply, like say 100 bags of corn, consumers or buyers are willing to buy the same exact 100 bags. So supply equals to demand. So those forces come into balance. So I'm going to share my screen for chapter 4. Then we can talk about it again on the other side. So let me share it here. Then we progress from there. So here's your chapter 4. So it's a chapter on equilibrium, how supply and demand determine prices. So here's going to be the outline of this chapter. We're going to talk about equilibrium and the adjustment process. And I'm going to talk about a free market, how a free market maximizes producer plus consumer surplus, or what we call the gains from trade. When markets are in equilibrium, that's when you get the most gain of consumer surplus and producer surplus. When markets are not in equilibrium, there's always going to be what we call some wasted resources or dead weight costs of resources. The question is, does the model work? So we were going to talk about some evidence from the laboratory. And then we're going to talk about how shifts in the demand and supply curves will affect equilibrium price and equilibrium quantity. Okay. And then we're going to talk about some terminology, demand compared with quantity demanded and supply compared with quantity supplied. And then understanding the price of oil. And then, of course, we always wrap it up with some takeaways. So here's the market is in equilibrium. So equilibrium is a price at which the quantity demanded is equal to the quantity supplied. So you could have your representation when you say quantity demanded, you can represent that by QD equals to quantity supplied. So this QD would be your representation for notation for quantity demanded. And then this is going to be your acronym for quantity supplied. So the whole idea is that when supply equals to demand, remember the demand curve slopes downwards and the supply curve slope upwards. So the equilibrium is gonna be the point of intersection between the demand curve and the supply curve. So as you see illustrated in this diagram, our supply curve slopes upwards and the demand curve slopes downwards. So this point of intersection is what we are calling equilibrium point. And then the resulting price, you see, when you draw a line from that point of intersection to the vertical line, that determines equilibrium price. And then you draw the line down here because we read quantity down. Okay, now, when we put supply and demand together and we're talking about equilibrium, we no longer talk about equilibrium supply or equilibrium whatever. We just call it equilibrium quantity. We no longer call this quantity supplied or quantity demanded. We just call it equilibrium quantity. Because that's a point where supply equals to demand. So in this case, the equilibrium price of oil is $30 per barrel, and then equilibrium quantity is 65 million barrels that will be produced a day, produced and consumed a day. So when the market reaches equilibrium, that means all the 65 million barrels of oil that have been produced per day, MBD stands for millions of barrels of oil produced per day. So 65 million barrels of oil produced a day will also be bought in a day. So supply equals to demand. Okay, so equilibrium occurs again at the intersection of demand and supply curves where quantity demanded and quantity supplied are equal, and equilibrium price and equilibrium quantity are only factors that are stable in a free market. So equilibrium price and equilibrium quantity is what we call, those are stable equilibrium values. At any other point, economic forces will push price and quantities back to equilibrium. I'm going to talk about it shortly. So let's talk about what if markets are not in equilibrium? What if we are not operating at this point of intersection? Or let's assume that the price of oil is above the equilibrium. Let's say it's at $40. Then what you're going to see, if you draw a line from that $40, which curve do you hit first? You hit the demand curve first. Meaning that at that price of $40, quantity demanded is going to be here. You read it down here. And yet, at the same price, $40, producers want to supply this much quantity of oil. So quantity supplied is going to be this much. So this gap here, when the market is not in equilibrium, this is going to result into excess supply, or what we call a surplus. A surplus, or you can also call it excess supply of goods and services. So anytime the price of the good is above equilibrium, like $40 here, above equilibrium price, you can see that consumers want to demand less because it's expensive, but sellers want to sell more because they make more money. So they're going to, since they want to sell more, they're going to end up oversupplying the market with goods and services more than what the consumers want to demand. So we put numbers here. This QD could be something like, maybe you could think about, let's just hypothetical, it could be 55, and this QS could be 75. Okay, so this difference here, which we're calling surplus, you can read it from down here. So 55 and 75, that difference is what? Is 20. 75 minus 55 is $20. $20. So that means if the market is market price is $40 set above equilibrium, there's going to be an excess supply of 20 million barrels of oil that will be produced per day that nobody wants to buy. So sellers are going to be stuck with that 20 million barrels of oil that they produce per day that nobody wants to buy. So now you ask yourself, what do you think is going to happen when sellers are stuck with something that they cannot sell because the market price is so high? So anytime the market price rises above equilibrium, that results into excess supply. Sellers, for them to sell that excess 20 million barrels of oil that is available on the market that nobody wants to buy because the price is high, they're going to start decreasing the price. That's the only way you can get rid of it. So price eventually is going to start falling back to equilibrium. But at this point, when the price is $40, you are on this point on a demand curve. You could level that point A. And we are on this point B, on the supply curve. So from the law of demand that we talked about in chapter 3, when the price starts falling, a fall in the price means you move along the same demand curve. So you're going to start moving this way. And at a price of $40 per barrel of oil, we are on this point on the supply curve. And from the law of supply, when the price starts falling, you move along the supply curve downwards. And that continue moving until when the price comes back to $30 and we reestablish equilibrium. So that's why we're saying that this equilibrium becomes a stable equilibrium. Because when markets are not in equilibrium, the market forces of supply and demand will act as if to push the market price back to equilibrium. And that's exactly what happens. Okay. So I talk about surplus. So surplus is a situation in which quantity supplied is greater than quantity demanded. That happens when the market price is above equilibrium. So I'm going to maybe add here, this happens when the market price is above the equilibrium price. Is above the equilibrium price, like I already explained earlier on. Okay. So let's see here. So that's an equilibrium point there. So that's what we're talking about, surplus here. So for this case, we're assuming that the price of oil was 60, the equilibrium price was $60. See that? I don't know whether that's, yeah, there should be $60. And equilibrium quantity was 700, what? You locate this point, 700 barrels. Okay, now what if the market price turned out to be 75? Like I told you. So you draw a line, see the dotted line from 75, you hit the demand because the demand curve is a black line. So you read the quantity, this would be that means that the buyers of oil want to buy up to 500 million barrels a day when the price is $75. Meanwhile, the sellers of oil or oil producers, they want to supply 900 barrels of oil when the price is $75. Because they're supplying 900 barrels per day and buyers are only buying 500, that means there's going to be an excess supply of oil, which nobody wants to buy. Which buyers, the producers, oil producers are going to be stuck with it. And is what? That is going to be 400. 900 minus, because you read that gap from down here. This gap here. 900 minus 500 is 400. So there's an excess supply of 400 million barrels of oil that oil companies will be stuck with. That's what we're talking about. So surplus is a condition in which quantity supplied is greater than quantity demanded. See, because at a price of 75 again, quantity supplied is here is 900. Yet quantity demanded is what? 500. See, that's why we're saying QS is greater than QD. So this gap here, which is going, you read with 900 minus 500 is going to be the what? The size of the surplus. Okay. So here's your self-check. When there is a surplus in a competitive market, what will happen to price? I talk about that. Anytime there's a surplus of goods, the market price will tend to fall because producers are stuck with what they will never sell. To be able to sell that good, you need to lower the price. You need to induce consumers to buy that extra supply. And that's exactly what happens. So the takeaway, the self-check here is that when there's a surplus in a competitive market, price tend to decrease. So the correct answer is B. Okay. On the other hand, what about if the price is set too low, below equilibrium? Okay. So a shortage in which quantity demanded is greater than quantity supplied. That's what a shortage is. A situation in which quantity demanded is greater than quantity supplied. When quantity demanded is greater than quantity supplied. This kind of similar to black shopping on a Black Friday. What happened on a Black Friday? The sellers they cut the price below equilibrium. So people break doors at Walmart, at Best Buy, wanting to buy electronics. The demand becomes so high because the price has been chopped so much below equilibrium, and yet the supply is going to be small. So if you're a lazy shopper like me, and you wake up on a Saturday morning after Black Friday, you're not going to find anything left over at that price. Price would have cropped back to where it was, back to equilibrium. Okay, so now we can, so a shortage occurs. This occurs, add a line here, when the market price is below the equilibrium price. That is what results into a shortage. Equilibrium results is when market price is below the equilibrium price. So now let's look at what it is here. See, for this example, the equilibrium price is 60. And then equilibrium quantity is 700. That's before. So I can draw a straight line. Okay. Now, suppose the price is $55 per barrel. That price is below the equilibrium price, below 60. So we want to see how many gallons of gasoline, millions of barrels of gas of oil that oil companies want to supply at that price. So when the price is $55 a barrel, you draw a line, you hit the supply curve. The supply curve is a green line. You hit the green line, you read the quantity supplied here. So that means the producers of oil will want to supply 500 million barrels per day when the price is only $55. But because the price is too low, buyers of oil find that attractive. See? So you continue with the dotted line, you hit the demand curve after the supply curve. See, this is the demand curve. So you're going to read, this is going to be the quantity demanded at that price. So you can see clearly when the market price is below equilibrium, such as 55, quantity demanded, which is 900, exceeds quantity supplied, which is 500. So there's going to be a shortage of oil of 400 million barrels that we produce per day. We need a shortage. So in that case, quantity demanded is greater than quantity supplied. See, we talk about the QS is 500, QD is 900, so the difference is 400. Okay, and anytime there's a shortage, as I say, when consumers want to buy more than what is being supplied in the market, what do you think is going to happen to price? The price is going to increase back to equilibrium. So you can see I put an arrow pointing upwards. So that is the adjustment process. Anytime the price of a good is below the equilibrium, which results into a shortage, the price will be forced to be increased back to equilibrium. So the equilibrium point becomes a stable equilibrium. That if the markets are not in equilibrium, the market forces of supply and demand will act as if to push the market price back to equilibrium price. So here's your South check. When there's a shortage in a competitive market, price will increase. That's the correct choice. Because buyers want to buy a lot, and yet the sellers have only supplied limited amount. So that price will increase. So excess demand, or what we call shortage, is going to force the market price to increase back to equilibrium. So now let's talk about equilibrium and gains from trade. So a free market maximizes the gains from trade. We know that. Available goods are bought by the buyers with the highest willingness to pay. And goods are sold by sellers with the lowest cost possible. So between buyers and sellers, there are no unexploited gains from trade or any wasteful trades. These three conditions imply that the gain from trade are maximized. Okay? So when the market is in equilibrium, the producer surplus, remember the producer surplus is the area above the supply curve but below the market price. So let's say the market price, the equilibrium turns out to be 70. This would be your what? Let me draw this. This would be your, this area, this triangle here represents your what? Your producer surplus. Let me put it in a dot with black. And then let me change the color a little bit. Then this one marked with red, this dotted red, this area of this triangle up here, that represents your what? Your consumer surplus. Because the consumer surplus is the area of the triangle below the demand curve but above the market price. So this triangle here represents your what? Your consumer surplus. The one I'm locating red, that triangle. And the one down here is your consumer surplus. So what I'm saying is that when the market is in equilibrium, the total consumer surplus and producer surplus is maximized. When markets are not in equilibrium, it results into some kind of dead weight cost, some wasted resources. Okay? For example, let's talk about unexploited gains from trade. So any trade, okay, so when you say, let's say, this is your supply curve, your demand curve. So the demand curve, yes, is telling you that buyers are willing to pay up to $90, okay, for this quantity here. If you produce 50, you draw, how do I know that? You draw a line up to the supply curve. So that means the sellers are willing to sell, the minimum price they're willing to receive is at least $50. But the buyers are willing to pay up to a maximum of $90 when this quantity is produced. So any trade between $50 and $90 will make both parties better off. Because the buyers are already willing to pay up to $90 for these 50 units of what? Of oil that is produced. And sellers are willing to accept at least a minimum price of $50 for this barrel of oil produced, for the 50 units of oil produced. So any trade between $50 and $90 would be desirable and will make both buyers and sellers better off. So this shaded kind of like Like shaded orange looking or triangle there, that is going to be what we call unexploited gains from trade. So sellers and buyers can still exploit that area. Okay. We can also think about cases of wasted resources. Suppose quantity is greater than equilibrium. Okay, say 90. Suppose we have produced 90. Okay. So at 90, quantity of 90, buyers, they're willing to pay $50. And then you see, this is sellers are willing to supply for $90, but buyers are willing to buy only for $50. So this is going to result into wasted what? This trade is not going to take place. Remember that. That is not going to take place because in this case, at that quantity, how do I know the price buyers are willing to pay for this $90, 90 million barrel of gas of oil per day, produced per day? You draw the dotted line and you hit the demand curve. That's the price they're willing to pay. The buyers are willing to pay. But the price that sellers are willing to sell that $90 unit, you have to continue until when you hit the supply curve and you read the price that they're willing to receive for that whatever $90. So sellers are asking for a far much higher price than what the buyers want to pay. So you will never sell this quantity. Okay, so that results into some kind of wasted what? Wasted resource. So sellers will not sell units they are losing money on. You don't want to. You want $90, but someone only wants to pay $50. So because you're not willing to sell, this kind of amounts to some kind of wasted resources. Okay. So if the quantity traded is less than the equilibrium quantity, okay, if the quantity traded is less than the equilibrium quantity, okay, if the quantity traded is less than the equilibrium quantity, like what we talked about here. So when you go back, okay, some gains from trade will be lost. So you see, because we talked about it, this is the first case when the quantity traded is less than equilibrium quantity, because equilibrium quantity is here. Some gains will be lost. Okay, that's true. Okay, let's talk about some evidence from the laboratory. So in 1956, some guy called Vernon Smith tested the supply and demand model in a lab. The model accurately and consistently predicted market behavior. In 2002, Smith was awarded the Nobel Prize for establishing laboratory experiments. That's an important tool in economics. Okay, see how we economics can take us, far, right? So now let's talk about shifting the demand curve and the supply curve that we talked about earlier. But remember when in chapter 3, when we talked about shifting the demand curve and supply curves, we were doing that in isolation. We were only looking at the demand curve separately and the supply side of the market separately. But now if we're in the equilibrium context, you learn the factors that shift the demand curve and the factors that shift the supply curve in chapter 3. For example, in chapter 3, we say when there's a technological advancement, there's an increase in technology, we produce more. So that means we shift the supply curve to the right. Okay. And that can create a surplus of goods. You see that? So for example, you can see that if you shift the demand, so an increase in supply, and the factors that will lead to an increase in supply, we shift the supply curve to the right. We talked about in chapter 3 could be things like lower input prices, lower energy costs, lower raw material costs, you know what I mean? Cost of raw material goods are decreasing. There are going to be things like higher technological advancement. So when we shift the supply curve to the right, if this price remains, then that's going to result into, because the producers are now will be supplying now this much quantity at that price. Okay, so that's going to lead to some surplus. And when there's a surplus, what do you think is going to happen? Surplus leads to a decrease in equilibrium price. So price eventually is going to fall. And remember, at that point, we are on this point on a demand curve. As price falls, consumers are going to want to demand more. And as price fall, sellers are going to demand less, just want to sell less. So we're going to end up at this new equilibrium where the red line intersects the blue line. So equilibrium quantity is going to increase in general to, like, say, some new level, and equilibrium price eventually is going to fall to a new level. PA prime, maybe QA prime here. So that's a dynamic in the market. When the supply curve shifts to the right, this equilibrium is no longer relevant. We're gonna what? We're gonna move to a new equilibrium. The market price is gonna fall, and the equilibrium quantity is gonna go up. See that? Okay. So let's self-test your check. So a decrease in supply will do what? So what about even the supply curve decrease? So now you cannot work these things in your head. And sometimes I may be very specific. I could just say, you know, the factors that will decrease supply. They could be things like higher energy price, higher raw input prices, higher labor costs, lousy technology. We already discussed that in chapter 3. So when I say, you know, that I can bring down, suppose there's an increase in what? In input prices or in cost of raw material goods. We know that is gonna draw the graph. That means, so you always want to start at a point when things were nothing had changed. So let's say this was my initial supply curve, S1, and let's say this is my demand curve, D1. This was my initial equilibrium, Q1, equilibrium quantity and equilibrium price, P1. Now, what I'm saying is that suppose there is a decrease in supply. A decrease in supply means the supply curve is going to shift to the left. And this, I'm being very general. Sometimes I may be a little bit more specific. I could just say, suppose there's There's an increase in energy costs or an increase in the price of raw material goods. You know that is going to shift the supply curve to the left. It leads to a decrease in supply. So, and you know, always want to use an arrow pointing this way, meaning that the supply curve. Oh, I'm sorry, I made a mistake here. Sorry, we'll have this. I labeled the curves kind of. Forget about that. I labeled these curves with a wrong name. I'm calling supply demand and demand supply. That's wrong. Sorry about that. That tells you that it has been a long day for me. Okay, so let's draw it. So what we're gonna do, we're gonna say, okay, here is we put price here, put quantity here. So see, I labeled this D instead of S. The supply curve slopes upwards, the demand curve is the one that slopes downward. See? So this was my initial equilibrium quantity, Q1, and my initial equilibrium price. Now, what we're saying, suppose there's a decrease in what? In supply. A decrease in supply means the supply curve shifts to the what? To the left. So you're going to shift the supply curve to the left to S2. Then you draw an arrow showing that. So the new equilibrium is where the new supply curve, the red line, intersect the blue line, which is this point here. That is going to lead to a decrease in equilibrium quantity, and that's going to lead to an increase in equilibrium price. See that clearly. Okay? So the correct choice here is that a decrease in supply is going to lead to an increase in price and decrease in quantity. So C is the correct choice. You can see it from your graph. You draw and you can see when you decrease supply, equilibrium quantity is going to decrease and equilibrium price is going to go up. So the correct choice has to be C. Price will go up. So make sure you practice this during your free time. Practice and practice and practice. Draw as many graphs as you can possibly do. And in Achieve, there are work examples. You can go try yourself. Try most of the examples there. Okay. What about if the demand curve is the one shifting? Okay, let's say, and again in chapter 3, sometimes I may say, suppose there's an increase in demand. Okay, So when there's an increase in demand, so let's draw a graph. I could be more specific. You already know the factors that will decrease the demand for a good, and the factors that can increase the demand for a good. Okay, so there are going to be things like consumers' income. When the good is a normal good, the demand curve is going to shift to the right when consumer income goes up for normal goods. It shifts to the left when income increases when the good is inferior. We talked about the price of complementary good. When the price of gasoline goes, the price of a car goes up, we say that leads to a decrease in the quantity demand, a decrease in the demand for what? For gasoline. So when the price of a car goes up, fewer people are going to buy cars. Therefore, fewer gallons of gasoline will be demanded. So you know those factors. We talk about that. So here I'm just going to say in general, I suppose there's an increase in demand. This increase in demand could be, as I said again, it could be maybe due to increase in consumer income, as I said, or it could be due to a decrease in the price of a complementary good. Like the decrease in the price of cars will lead to an increase in the demand for oil. Because when the price of cars falls from a low of demand, many people are going to buy cars. And when many cars are bought, they need more gasoline. Okay? So, but you just want to understand this. So now we draw this. Always don't work these problems in your head. Draw it, because you work in your head, you're going to be wrong. P, Q. So if this is my supply curve, we can call this supply 1, and this is my demand curve. You can call this D1. This is my initial terminal equilibrium point and terminal equilibrium values of Q1 and P1. Now, what I'm saying is that suppose there's an increase in what? In demand. That means the demand curve is the one shifting. An increase in demand means you shift the demand curve to the right, to say D2. So you can see clearly the equilibrium is going to move to this new point, the point where the blue line intersects the red line. So that's going to lead to an increase in equilibrium price and an increase in equilibrium quantity. See, the new quantity is now at this point, the new price at this point, so price goes up. So an increase in demand leads to both an increase in price and an increase in quantity. See? What about decrease in what? Demand? Decrease in demand is going to lead to a decrease in price and a decrease in quantity. So no. Yes, decrease in both price and quantity. Equilibrium quantity about both going to decrease. You can practice that. A decrease in demand will decrease both price and quantity. So A is a correct choice for sure. Lower demand causes a surplus, lowering price and causing suppliers to supply less. So there's a big difference between demand and quantity demanded. We already talked about that already. A change in demand and change in quantity demanded. We did that in chapter 3. And you're going to see that. So the most important thing that you got to know, there's something that has gone. I want you to understand this very well now. Let me show you that anytime you shift the demand curve, which is what we call a change in demand or an increase in or decrease in demand, that is going to lead to an increase or decrease in quantity supply. Okay? So I'm going to show you this. Because remember, what is a change in quantity supplied? Quantity supplied is when you're moving along the same supply curve. So when the demand curve is shifting, you move along the same supply curve. Okay, let me show you that. So I say a shift in the demand curve, a shift in demand in the demand curve, which we call what? We call what? A change in demand. Because a change in demand involves shifting the entire demand curve. A change in demand leads to a change in quantity supplied. When I say it leads to a change in quantity supply, that means it leads to a movement along the same supply curve. A movement along the same supply curve. And the converse is true. If we shift the supply curve instead, that would be interpreted as a change in supply. That is going to lead to a change in quantity demanded. In other words, we're going to be moving along the same demand curve. When you shift the supply curve, you move along the demand curve. When you shift the demand curve, you end up moving along the supply curve. So let me just draw one. I think I already have examples here. You see, for example, here, if you shift the demand curve to the right, you move along the supply curve from this, because the initial equilibrium was when the two blue lines intersect. See here? But once you shift the demand, the demand curve to the right in this case, we end up at this point. So that you end up moving along the same supply curve. That's going to lead to an increase in quantity supply. The same thing, the similar things here. When you shift the supply curve, you move along the demand curve. That leads to an increase. Shift the supply curve to the right leads to an increase in quantity demanded. So a change in supply is a shift of the entire supply curve. A change in quantity supplied is a movement along this fixed supply curve. So increase in supply and quantity supplied, we talked about that already. Increase in supply is when what? You're shifting the entire supply curve. You end up moving along the same demand curve. And then an increase in quantity supplied is when you shift the demand curve, you end up moving along the same supply curve. I will skip the understanding oil price. That's just a kind of a little bit of case studies. I guess go to takeaways right away. So we can use supply and demand to answer questions about the world. But before I talk about case studies, there's something that your book does not do, because I want you to understand this thing in depth. Right now, we have been shifting supply curves. When supply curve shifts to the right or to the left, we hold demand curve constant. When the demand curve shifts, we hold supply constant. But there are also cases where supply curve and demand curve could simultaneously shift. That becomes a little tricky. So let me discuss those cases. It might not be in your textbook, but it is additional material that I feel is crucial for you to know. So I'm going to talk about here. We can talk about simultaneous shift in demand. DD stands for demand, and supply curves. SS stands for supply. So sometimes the demand curves are going to shift, okay, simultaneously with supply. They all shift at the same time. So I want to do one or two examples to solidify how. Then the question is, how would you analyze what happens with equilibrium price and equilibrium quantity? Okay, so let's do that. So I'm going to give you one example here. Example. Say a new technology leads to an increase in the production, including the production of orange juice. Production of orange juice. Then I say at the same time, a medical report indicates that drinking orange juice leads to a terminal illness. Maybe it can cause cancer, terminal illness like cancer. So now think about it. There are two things that are happening from both sides of the market here. one thing for sure, the new technology is good for, we get farmers, people produce our orange juice. Most of our orange juices come from Florida. So the farmers are going to be able to get us the citrus, to massively produce orange juice for us because of that new technology. But at the same time, there's a medical report that is saying that when you drink too much orange juice, it increases the likelihood of contracting a terminal illness. So this medical report is affecting the demand side of the orange juice market. You see that? The new technology is affecting the supply side. So now the first thing is, so now the question I'm going to ask you, so that's the statement now followed by the question. I can now say, analyze and conclude what happens to equilibrium price and equilibrium quantity for orange juice. Equilibrium quantity for orange juice. Okay, so two events are happening. Technology allowing, okay, so now you need to summarize that. So you know for a fact here that new technology, you summarize it, you start your solution here. New technology is going to shift the what? We know this shift the supply curve to the right. The medical report, which in a statement that I had all in the previous slide, medical report that's saying that drinking orange juice causes an illness, that is going to shift the demand curve to the left, because when consumers hear that, they're not going to buy too much orange juice. This shift the demand to the left, leads to a decrease in demand. But the problem is we have not been told by how much the demand and supply curve is going to shift. Say that the question did not tell us. You go to the statement here. It just says a new technology leads to an increase in the production of orange juice. At the same time, a medical report indicates that drinking orange juice leads to a terminal illness. Okay? The question has not mentioned whatsoever the magnitude that by which both the demand and the supply curve will shift. So you need to, so once the question is just, we know both curves are shifting at the same time. To be able to figure out what happens to equilibrium price and equilibrium quantity, you need to draw three cases. Okay. So to do that, look, I want you to follow me clearly. You're gonna say okay, so we're gonna have three cases here. So case one, and it doesn't matter, it can go in either order. Case one, you can assume that demand shifts more than supply. Because we have not been told, you need to, more than supply. And then you're going to draw that case. This is a case where the demand shifts more than supply. So we put price here, we put quantity here. So let's say this was my initial demand for orange juice, D1. This was my initial supply for orange juice, S1. And this was the terminal equilibrium values for price for orange juice before any of those events happen. Now, there's a new technology that leads people in Florida to produce more orange juice. And there's a medical report that affects consumers' demand for orange juice, shifting demand curve to the left. But now, in this case, we're seeing that the demand curve is going to shift more than supply. What do I mean by this? That means the shift of the demand curve, we know the demand curve is going to shift to the left. It's going to shift a lot to the left, to say by D to D2. Excuse my drawing. This should be a straight line. It's crooked now. Straight line. Okay. But we know that the new technology is going to shift the supply curve to the what? To the right, but somewhat. This one, I said, when I say demand shifts by more than supply, you can see that the magnitude of the shift of the demand curve is way more than the magnitude of shift of the supply curve to the right. So in this case, The new equilibrium is going to be where the two black lines intersect, where the new supply curve S2, this line here, and this new demand curve D2, which they intersect here. So equilibrium quantity in this case is going to fall. You can see clearly. And equilibrium price will also fall. So under this case, you're going to document here, P falls. I'm just going to put the arrow going down. P decreases, Q increases. That's case one. But that's not the only case. Then you have to do case two. What about the case two is going to be a case where we're going to assume that one. The supply curve is going to be shifting disproportionately more than the what? The shift of the demand curve. Okay? So case two, we can say case two, we can say supply shifts more than demand. Okay? So we know that that's going to look like this. Let's analyze this second case. So you get price, you got quantity here. So this is my S1, this is my D1. So before anything happened, this was the terminal equilibrium values for quantity, equilibrium quantity Q1, equilibrium price P1. Now, all of a sudden, we have been told that what? The medical report says that what? Drinking too much orange juice increases the likelihood of contracting a terminal illness. So the demand curve is shifting to the left, but shifts by very small magnitude in this case. Because we're saying that supply shifts more than demand. The new technology is going to shift supply curve to the right by bigger magnitude than the shift of the demand curve. See this? This is what I mean by supply shifting by greater magnitude than the shift of the demand curve to the left. Okay. So this is coming here. So the new equilibrium is going to be where the two red lines intersect, where the new supply curve S2 and demand curve D2 intersect, which is this point. So that's going to lead to an increase in equilibrium quantity, but price still decreases. See, the new equilibrium price is lower than the previous one. So under this case, P still falls. P decreases, but equilibrium quantity still increases. Then the last case that you draw is a case where you're going to assume that what? Demand curve and supply curve shift proportionally by the same magnitude. Right? They're going to be shifting proportionately by the same magnitude. Okay? So we can say, so case three, we're going to say demand and supply shift by the same size. Okay? So when they shift by the same size, here's what's going to happen. I want to see what happened to equilibrium price in this case. So you get P and equilibrium quantity. So here's my initial supply curve S1. Here's my initial demand curve D1 before anything changed. This is my initial terminal equilibrium Q1 and terminal equilibrium price P1. Now, in this case, we are saying that what? The shift of the supply curve and the shift of the demand curve are the same. But we know the supply curve shifts to the what? Shifts to the right. Like that. S2. So now under this case, you can see clearly, if I want to make, my drawing might not be very cute here. We know the demand curve is shifting to the left, sorry. Supply shifts to the right, demand shifts to the left, so we want to be here. So demand curve shifts this way. Because the new, see, by the same size, see? So under this, see the magnitude of the shift is the same. They all shift by the same magnitude. So under this case, you can see the new equilibrium is where the two red lines intersect. Price still falls in this case, but the change in equilibrium quantity is constant. Equilibrium quantity stays the same. So here, P falls, Q stays the same under this case. Okay, now we go back and look at all the three cases. When we assume that demand shifts more than supply, supply shifts more than demand, and when they shift by the same magnitude. In the first case, you see price falls and quantity increases. Second case, price falls, quantity increases. Third case, price falls, quantity. So now we can conclude with all the three cases, your conclusion would be that when a medical report says that drinking orange juice increases what? Likelihood of what? Contracting a terminal illness, and a new technology raises the production of orange juice, the resulting impact on equilibrium price and equilibrium quantity, for sure, we know that equilibrium price in all three cases will what? Will fall. That's what our analysis has shown. Equilibrium price, for sure. So this is your conclusion. Equilibrium price will fall. But equilibrium quantity will increase, decrease, or stay the same. Or another way of saying it, you could just say the change in equilibrium quantities is ambiguous. Okay? Or you could just say, or you can just say change in equilibrium quantity is ambiguous. Ambiguous or uncertain. Ambiguous means uncertain. You mean either increase, decrease, or stay the same. Unless I ask you a question specifically on the test, where I could say a question on the test, the same question, where I say, a new technology leads to an increase in the production of orange juice. At the same time, a medical report, just like here. But then I say, the impact of the technology on the supply side was more pronounced than the medical report's impact on the what? On the demand side of the market. Then you know you only have one case to draw. The technology impact is more, you're going to draw that case where the supply curve is going to shift to the right more than the shift to the left of the demand curve. But if I don't tell you, you need to draw all three cases and be able to conclude what eventually happens to equilibrium price and equilibrium quantity. Okay? That's the way to go. And then I can do one more example here for this, so that to solidify our understanding here. So let me do one more. Cases where what? Supply and demand shift disproportionately. So they're all shifting at the same time. Something happened during the Bush administration. Okay. So in 2005, Hurricane Katrina it was it was really bad, destroyed, I like writing with this, destroyed major pipeline infrastructure along the Gulf Coast, which is used for what? Which is used for transporting natural gas. To our homes. At the same time, the winter of 2005 was unusually cold. See that? The winter of 2005 was unusually cold. Okay. So now, with those in mind, I'm going to ask you here to, we're going to say, let's analyze what happens. What? Analyze what happens. I didn't spell analyze well there. What happens to equilibrium price and equilibrium quantity of natural gas. Equilibrium quantity of natural gas. Okay, so you know two things are happening at the same time. The hurricane hit and destroyed major pipeline infrastructure along the Gulf Coast, which is used for transporting natural gas. So that means when the hurricane destroyed pipeline infrastructure, that affected the supply of natural gas to our homes. So that's going to lead to a decrease in the what? In the supply of natural gas because pipeline infrastructure had been destroyed. But at the same time, the winter of 2005 was unusually cold, meaning that the demand for natural gas, people are demanding more gas for heating their homes. See that? So here are two events happening at the same time. Okay, so now we want to show what could have happened to equilibrium price and equilibrium quantity for natural gas during the winter of 2005. Okay, so let's do it here. So first of all, you know that what? This is your solution, your summary. You need to know which curve shift and which direction first. That's what you need to know first. So we know that hurricane hurricane destruction. We know that that's going to lead to a decrease in what? A decrease in supply of natural gas. Because hurricane destroyed pipeline infrastructure. So that means the supply curve is going to shift to the what? To the left. A decrease in supply means you shift the supply curve to the left. Okay, and then the cold winter means an increase in the demand for natural gas. So you need to first know this, an increase, because if you don't know which side, which curve, which curve is shifting, then you cannot even proceed. Or if you proceed, you're going to get it wrong. If you proceed without knowing precisely which curve shifts in which direction, then your answer is going to be wrong. So the first thing is to first know which curve will shift and in which direction. So this is going to lead to an increase in demand. Increased demand means the demand curve shifts to the right. But we have not been told whatsoever the magnitude of the demand shift and the magnitude of the hurricane destruction on the supply side of what? Of natural gas. So we have to have three cases, just like we did for orange juice. So you're gonna go case one. And you can assume case one, you can begin with anything. The order doesn't matter, remember. Case one, you're gonna say a case where demand shifts more than supply. Then draw it. So if it is a case where demand is going to shift more than supply, I'm going to draw my graph here. So price goes on this axis, quantity goes on this axis. So this is my demand for natural gas. I can label this D1. This is my supply for natural gas. You can label it S1. This is my initial terminal equilibrium values for price and quantity, Q1. Okay, now we know that the hurricane hitting, the winter being so cold, led to an increase in the demand for natural gas, and the demand is going to shift more. So that means the shift for demand curve to the right is a lot. Demand shifts to the right by huge magnitude. And the supply curve is going to shift to the left because hurricane destroyed pipeline infrastructure. So that means the supply of natural gas is going to fall, meaning that a decrease in the supply of natural gas. But since we're saying demand shifts more than supply, that means the magnitude of the shift of demand curve has to be larger than the magnitude of the shift of what? Supply curve. So in this case, the new equilibrium is going to be where the two red lines intersect. where the new demand curve and the new supply curve intersect, which is this point. So you can see clearly, then we can connect here, we can locate our new equilibrium what? Quantity. And new equilibrium price is going to be right on that axis. So under this case, price is going to increase. Price increases. And quantity, equilibrium quantity is going to increase as well. See that? They both increase. That's case one. Then you have to look at case two. So case two, we can assume that the supply for natural gas is going to shift to the left disproportionately more than the shift to the right of the what? Of the demand for natural gas. So case two, we can say supply shifts more than demand. Okay, and then let's draw that case. So if supply shifts more than demand, we're drawing that case here. So we have price on this axis, we have quantity here. So here's my initial supply curve for natural gas. Here's my initial demand curve for natural gas before anything happened. Locate those initial terminal equilibrium values, Q1 and P1. Now, the demand for natural gas shifts to the right, but it's going to shift somewhat. So this is your new demand curve, D2. Supply curve shifts to the left, but by bigger magnitude. See, S2. So under this case, the new equilibrium is going to be a point where the two black lines intersect, which is that point, where the new supply curve intersect the what? The demand curve. So in this case, you can see clearly the equilibrium quantity is going to fall. And equilibrium price still increases. Then you got to draw the last case and you make conclusion. The last case is where you always assume that what? Both demand and supply are going to increase, are going to shift by the same magnitude. So case here is case 3, which is the last case. You're going to say demand and supply shift by the same size, by the same magnitude or same size. Okay, so let's draw that case. You get price here, you get quantity here. This is my initial supply, initial demand curve. This is my initial terminal equilibrium values for quantity, Q1, equilibrium price, P1. And then in this case, we know that both curves are shifting by the same magnitude, where we know the demand curve shifts to the right. Winter is cold. People needing to heat more of their homes, meaning the demand is going up. And then the supply curve is shifting to the left by the same magnitude, see? S2. So you see this kind of similar magnitude. So under this case, price still goes up, see? See, price is still gonna go up to P2. But quantity now remain the same. So in this case, P increases, but equilibrium quantity stays the same. Then now you're gonna make the, so now you after you have drawn all those 3 cases, you know our price and quantity, equilibrium price and quantity is behaving in all 3 cases, you now make conclusion. So you're gonna conclude here. Conclusion. So what do we see in all 3 cases? In all 3 cases, price increases in all 3 cases. Okay, but the change in equilibrium quantity is ambiguous. Equilibrium quantity either increase in case 1, see, then it decrease in case 2, and it stayed the same in case what? In case 3. So we can just say, under all 3 cases, equilibrium price will increase. Equilibrium price for natural gas, people will pay a higher price for that. Equilibrium price for natural gas increases, for sure. But the change in equilibrium quantity is uncertain. Uncertain is the same thing as ambiguous. That means equilibrium quantity will either increase, decrease, or stay the same, just like we saw that. Okay. So so now these are just the key takeaway, the summaries. So this concludes our discussion of demand and supply. So chapter 3, again, we laid it out. We talked about the supply and the demand side of the market for oil separately. And we learn about factors that shift. So your main goal is to understand clearly, isolate factors that if I'm studying, I'm studying, I write those factors that we discussed, which affect the demand side of the economy, of the market, and factors that shift the supply curve of the market. And then you can, that's how you understand. Then you start talking now down to this chapter 4, which is the equilibrium. We just studied equilibrium, how the market reach equilibrium, and how when you shift the supply curve or the demand curve, how that changes equilibrium price and equilibrium quantity. It is that simple. Anyway, thank you very much again. I'm gonna do more recording. So the next chapter that I'm gonna be recording is gonna be chapter 5. So make sure you watch these videos. I'm gonna send you 2 separate links. A link for chapter 3 because I recorded them separately. It's gonna be a YouTube link for chapter 3 and a YouTube link for chapter 4. So you watch those videos separately. So up to this point, we have completed chapters 1 through 4. Thank you very much, and I'll see you guys next time. Happy 4th of July.